Right, so we're just going to go through these questions in the test. So hopefully you've got the test there that you can see. So I'm just going to go through like my answers, how I get my answers here. So number one, it's 1 plus sine theta plus tan 2 theta over 2 cos 3 theta minus 1. So first job is just put the small angle approximations in. So like 1 plus theta plus 2 theta over, and I'm just going to be careful with this one, 2 times, it says 1 minus theta squared in the formula book, 1 minus, no it doesn't, it says 1 minus a half theta squared, so 1 minus a half 3 theta squared minus 1, and it's just this that I'm going to take care of. I'm going to multiply by the 2 and then I'm going to square it. I'm going to do that in 2 steps though. So 1 plus 3 theta on the top, that's fine, and then over 2 minus 3 theta squared, take away 1, so that's 1 plus 3 theta over 2 minus 9 theta squared, take away 1, which is 1 plus 3 theta over 1 minus 9 theta squared. Okay, what's a bit shiny. Okay, and now I'm just looking at the denominator there, and that denominator is different to 2 squares, isn't it? So we've got 1 plus 3 theta over 1 minus 3 theta, 1 plus 3 theta. So therefore, that factor will cancel, so left with what I'm supposed to get, which is good. Okay, and then part B is saying, what if theta was really small? So imagine like theta was like 0.01 or something. So then you've got 1 over 1 minus 3 theta. So that's 1 over 1 minus something that's dead small, which is 1 basically. And that's just 1. And that's the end of that. That's it. That's why it's only 1 mark. Right. Okay, question 2. Try and fit it in here. Right, what I'm doing on question 2 here is I'm looking at this is 2 arcs of the circle. So this is 1 arc here, where that's the center, and this is another arc here where that's the center, and that's the part to understand really. So I'm going to draw that then. So I'm drawing the like rhombus first. Okay, so these are all 4, 4, 4, 4, 4, and this is 4 as well. Okay, and then I'm just interested in this bit there. Okay, so I'm going to work out that first. So that, what's it called? BCD. That's a sector of a circle. Let me work out the angles from that sector of the circle. So what have we got? Well, this is an equilateral triangle, so these are all pi over 3. So pi over 3 everywhere, pi over 3, pi over 3, pi over 3, and pi over 3. Okay, so then when I'm working that out, then I'm going to work out the sector BCD. So area of sector BCD, that's what, half r squared theta. That's a half times 4 squared times, so that angle then is 2 pi over 3. And when I work that out, then I have, so what's that, 16 pi over 3. Okay. And then what I'm going to do is I'm going to say, work out this white bit sort of thing. So take away that triangle and that triangle there. So area of triangle, well, let's say BCD, is a half AB sine C. So that's a half times 4 times 4 times sine 2 pi over 3. And put that in your calculator or whatever, and it comes out as, what is it, 4? Okay, so look 43. Okay, so then the rhombus is just double that. So the rhombus A, B, C, D is 2 of them, which is 8 root 3. Okay, so then those 2 grey bits then, like I'm going to colour them in green, like, but those 2 grey bits then is this sector here, take away this rhombus. So the 2, I don't know what you call them. I don't know what they are, like two small segments, I suppose. Yeah, so 2 small segments is 16 pi over 3, take away 8 root 3. So therefore the whole shaded area, oh, there we go, shaded area is double that. So it's 32 pi over 3 minus 16 root 3. And then it just wants you to factorise it in that funny way. So that is, take out a factor of 2/3, not really a factor of 2/3 there. You can sort of see it for this. What do we need to times 2/3 by there? 16 pi. But what do we need to times 2/3 by here? Bit of a strange question, like, but you can see if you put 24 root 3 in there and get that from the question, like 24 root 3 times 2/3 is 16 root 3. So there you go, that's the end of that question. Okay, so it was a funny one, but it started off by working out the angles, crucially, work out the sector, take away, well, really a triangle, but actually it was 2 triangles, this rhombus, and then double it then to get the actual answer to the question. Right, okay, so that was question 2. So question 3 then, it's just a sort of equation you solved in year 12. So like 2 cos squared x plus 1 equals 5 sine x. So the only difference here is that the answers need to be between 0 and 2 pi. So I'm going to factorise that. Not factorise it, replace it with 1 minus sine squared. And then multiply out the brackets. So 2 minus 2 sine squared x plus 1 equals 5 sine x. I'm going to get everything over here. So I've got 2 sine squared x plus 5 sine x, take away 3 equals 0. And then I'm just going to factorise that. If you want to, like, you can say, you know, where you say let sine x equals y, but I'm not going to. I'm just going to do it directly. So 2 sine x, I want that to be 5, so that's plus 3, and that's minus 1 equals 0. So either sine x equals minus 3, which is nonsense, or sine x equals a half, which I can solve on my calculator. So my calculator says x equals pi over 6, and then I need to get another answer, and I'm just going to do pi, take away pi over 6, or 5 pi over 6, and that's it. Yeah, sounds. That's the end of that question. Right, okay, question 4 then. So P of Q of X. So that means do Q of X first and then do P to it. So P of Q of X is, well, Q of X is 5 minus 2x, and then P of X says square it. So that's P of Q of X. Q of P of X means do P of X squared, P of X first, and then do Q to it. So P of X is X squared, and then Q to it says 5 minus 2 of them. So that's 5 minus 2x squared. And then the question is just saying, put them equal to each other. Okay. So 5 minus 2x squared equals, right, 5 minus 2x squared. So I'm just multiplying that out. 25, take away 20x plus 4x squared equals 5, take away 2x squared. I'm just getting everything over here. So then 6x squared, and also in a nice order, take away 20x plus 20 equals 0. Oh yeah, and then half it to get what we want. So 3x squared, take away 10x plus 10 equals 0. Yeah, nice one. And show that that's got no solutions. Well, what's b squared minus 4ac? That's, as soon as you see no solutions or anything, like, that's what you think of. And it's what? It's 10 squared, take away 4 times 3 times 10. So that's 100, take away 120. That's minus 20. And I'm just going to say, therefore, no real solutions. Okay, right, so that was question 4. And then question 5, really standard functions question this, you know. So what's the range of G? So I'm just looking here. So it says the domain is x is greater than or equal to -2. So the domain is all these x values. The range then is these y values up here. All right, that's what the range is. So the y values that the graph occupies. So we need to work out what that y value is there. In other words, what's the coordinate to that? We're just going to sub -2 in. So that's only 1 mark, like g of -2. So what I mean is, I'm not saying it's easy. I'm just saying there's not much work to do for that. G of -2 is 3 plus the square root of 0, which is 3. So the range is g of x is greater than or equal to 3. Okay, what about g to the -1? Well, I'm going to say y equals 3 plus square root of x plus 2. So y take away 3 equal, I'm just making x a subject to the formula, aren't I? So y minus 3 squared equals x plus 2. So finally x equals y minus 3 squared, take away 2. And then write it properly. G to the -1 of x is not y, but x. X minus 3 squared, take away 2. And then it says state its domain. It says state its domain. Like there's no work to do there. I've got no work to do. I don't need to draw no graph on it because I've already worked out the range. So the range of G is the same as the domain of G to the -1. And that's all I need to use there. So I've got the range there. So I'm just going to say then that's for x is greater than or equal to 3. That's all that is. So that there is the same as that there. That's the range because it's G. This is the domain because it's G to the -1. Right. And then a little bit of algebra to do here for part C. G of x equals x. Okay. So 3 plus square root of x plus 2 equals x. Take away 3. So x plus 2 equals x. Square root of x plus 2 equals x minus 3. Square both sides. X plus 2 equals x minus 3 squared. Multiply that out then. X plus 2 equals x squared minus 6x plus 9. So x squared minus 7x plus 7 equals 0. And then, well, that's not going to factorize, is it? So I'm just going to use the formula. So I've got x equals minus b plus or minus the square root of b squared minus 4ac, or put in your calculator if you want, all over 2a, which is 7 plus or minus root 21 over 2. Now, we've just said, haven't we, that, oh, actually, I don't know, actually. I was just wondering about whether we allowed the negative answer or not. So it wants to have g of x equals x, but oh yeah, sorry, it says, doesn't it? X has got to be greater than 3, so we're not allowed the negative answer. So we just have 7 plus root 21 over 2. Not sure if you'd lose a mark there. Well, yeah, you would, you know. So 7 plus root 21 over 2 is the answer. Okay. And then, right, hence state the value of a for which g of a equals g to the -1 of a. I'm just going to put the graph back on there. So when these are equal to, don't forget, g to the -1 is the reflection of g. So there's g to the -1 will be the reflection of that. So it'll look like that. But the point is they cross on the line y equals x. So certainly don't need to solve this, which would be a very complicated equation to solve. All I need to do is to solve that instead. And that's a trick that you always use in an exam. And that's why it's only 1 mark and there's no work to do. So the answer is just, you would just say like, g to the minus, what's the question? G of a equals g to the -1 of a equals a. And I've already solved that. So that is 7 plus root 21 over 2. Okay, and that's it. So yeah, have a look at that and see what you reckon there. Nice one.